And in this section, let's look into power series. A power series is an infinite series of this form. Is an infinite series of this form. Now, if the limit of an, the limit of an over an plus 1 at which n tends to infinity, if the limit exists, then the radius of convergence is equal to the limit of this an over an plus 1. That is the radius of convergence. Now we also have the interval of convergence and the interval of divergence. If the absolute value of x minus x naught is less than the radius of convergence, this is called interval of convergence. But if we take the absolute value of x minus x naught greater than r, this is called interval of divergence. Now let's look at these questions that we have here. For what values of x do the following converge? So for this series to converge, that means the absolute value of x here should be less than the radius of convergence, which is r. Now, the solution. The first one is the series from 1 to infinity of n raised to power n over n factorial. Now here, we can take our an to be 1 over n factorial. Take an to be 1 over n factorial. Close any value of x here and take the other as an. Then an plus 1 becomes 1 over n plus 1 factorial. Now we take the limit at which n tends to infinity of an over an plus 1, which is equal to the limit at which n tends to infinity of 1 over n factorial, that's an, all over an plus 1, that's times n plus 1 factorial over 1, which is equal to limit n tends to infinity of n plus 1 factorial. Now n plus 1 factorial is the same thing as n plus 1 and n plus 1 minus 1 factorial. That's what? N factorial. All over n factorial. And the answer is the limit at which n tends to infinity of n plus 1. Now this is n plus 1. N tends to infinity. So infinity plus 1 is what? Is infinity. That means the radius of convergence is infinity. So for what value of x do the following converge? So the interval of convergence, we take this x. The interval of convergence is less than what? Infinity. That means this series converges for all values of what? Of real number. It converges for all values of what? Of real number. That is, it converges for a bounded set. For any value of x that is less than what? Infinity. It converges uniformly and absolutely. Now the second one now. This is n factorial xn. So we covered any value of x here. Then we take our an to be n factorial. That means our an plus 1 will be n plus 1 factorial. So we take the limit at which n tends to infinity of an over an plus 1. That's limit at which n tends to infinity of n factorial over n plus 1 factorial, which is limit at which n tends to infinity, n factorial. Now this n plus 1 factorial is the same thing as n plus 1 and n plus 1 minus 1 factorial. That is what? N factorial. Now this cancel out. So that's the limit at which n tends to infinity of 1 over n plus 1, which is equal to 1 over infinity plus 1 is infinity when n tends to infinity. The answer is 0. So that means the radius of convergence is equal to 0. Whenever you have the radius of convergence as 0, that means the series does not converge. If the radius of convergence is 0, that means the series does not converge. Because the interval of convergence will be absolute value of x less than 0. And the absolute value of any number is always what? Positive. So there's no way the absolute value of x will be less than 0. So the series doesn't converge. So 0 less than absolute value of x less than 0 doesn't converge. So r is equal to 0 doesn't converge. Now see, let an be n, take n over 2 raised to power n, 3n plus 1. Then we close this x. So that means our an plus 1 now will be n plus 1 over, that means whenever you see n, put n plus 1. So 2 raised to power n plus 1 into bracket. 3n, that's 3n plus 1 plus 1, that's 3n plus 4. 3n plus 4. So the limit, the ratio, n tends to infinity of an over an plus 1 is equal to limit n tends to infinity n over 2n into bracket 3n plus 1 times 2 raised to power n plus 1, that's 2 raised to power n, 2 raised to power 1, then 3n plus 4 over n plus 1. Over n plus 1. So this is 2 raised to power n out, and this is what? 2 raised to power n, which is out. And that's the limit n tends to infinity of 2n, 3n plus 4 over 3n plus 1, n plus 1. So that's the limit to which n tends to infinity of 6n squared plus 8n all over 3n squared plus 3n plus n, that's plus 4n plus 1. Plus 1. So if we take the limit of this, divide all 2 by n squared, that's 6 plus 8 over n plus 3 plus 4 over n plus 1 over n. So this is 8 over infinity is 0, 4 over infinity is 0, 1 over infinity is 0. So 6 over 3 is 2. So the radius of convergence of this is 2. And the interval of convergence is x minus 1. So we take absolute value of x minus 1 less than r less than 2. So this is the intervals of convergence. From this absolute value of x minus 1 less than 2, we can find the extreme values. We can find the extreme values here, saying absolute value of x minus 1 less than 2 from inequality. It's the same thing now. Minus 2 less than x minus 1 less than 2. Minus 2 less than x minus 1 less than 2. So here, this is the same thing as minus 2 plus 1 less than x less than 2 plus 1. So that's minus 1 less than x less than 3. So the extreme values are minus 1 and 3. So we can test for this value when x is equal to minus 1. You can plug it here. And when x is equal to 3, you can also plug it here. So these are the intervals of convergence. Now D, let an be 1 over n 3 raised to power n. Cover this x. So that means our an plus 1 becomes 1 over n plus 1 3 raised to power n plus 1. So the limit n tends to infinity, which is an over an plus 1, becomes 1 over n 3 raised to power n times, this is n plus 1, and this is 3 raised to power n plus 1, that's 3 raised to power n, 3 raised to power 1, law of indices, all over 1. So this cancel out. 3 raised to power n out, so that's 3n plus 1 all over n. Now let's take the limit of this. That's 3n plus 3 all over n. So we divide all 2 by n. That's 3 plus 3 over n plus n over n. So 3 over infinity is 0, 3 over 1 is 3. So the radius of convergence is 3. And the interval of convergence will be the absolute value of x less than 3, which is minus 3 less than x less than 3, minus 3 less than x less than 3. That's the extreme value. Now the last one here, let an be 1 over 2n minus 1. Then our an plus 1 becomes 1 over 2n plus 1, 2 into n plus 1 minus 1. That's 2n plus 2 minus 1. That's 2n plus 1. That's our an plus 1. Then an over an plus 1 will be 1 over 2n minus 1 times 2n plus 1 over 1. So we can take the limit of an over an plus 1. N tends to infinity as the limiting value at which n tends to infinity of 2n plus 1 over 2n minus 2. So we divide all through by n, you get 2 plus 1 over n over 2 minus 2 over n. So 1 over infinity is 0, 2 over infinity is 0, 2 over 2 is 1. So that means the radius of convergence R is 1. And the interval of convergence, just need this values of x, this function of x. So that's the absolute value of x plus 2 over x minus 1 is also less than 1. That is the interval of convergence. So a power series is an infinite series which is of this form. of this form. And the radius of convergence is the limit of an over an plus 1, while the interval of convergence is when the absolute value of x minus x naught is less than r, while the interval of divergence will be x minus x naught greater than r. This is interval of convergence and this is interval of divergence. Thank you.